Full screen. Can you? Oh, you can all see. Andy, do you mind putting a little something under the stand, just to make it a little higher? No, it's already all the way down. I just need. Yeah. That will get really hot from the projector, so it'll start to melt. So as the class goes on, the projector will go. Perfect. Right, number 15, as you see, is quite similar to 14. So what you got here in 15? Battery of 12. Resistor here. Another resistor here. 1.2.
It's not resistant, it's not.
Yeah, that one is. But it has a 1.2 resistance, so. Again, when you close the switch, why will the voltage drop? Well, because the resistance increases. More resistance means more voltage is consumed. Now, next one. The voltmeter reads 11. So look. Oops. There's a voltmeter here, and the voltmeter reads 11. But please be very careful. The current is going this way around, clockwise. So it goes through here, and then around, and around, and around. So that 11 volts, although it's on the top of the circuit, it's actually 11 volts from here to here. In other words, it's actually the same as saying 11 volts across this resistor. So by using Ohm's law here, we get V equals I or 11 equals I 1.2. So can you tell me what the I is, please?
11 divided.
Yeah.
9.17.
What is it?
9.17.
Okay. Now, let's look at the whole circuit. And if you like, you can think about it as Kirchhoff's first law. So what's the voltage in the battery here? 12. And then as you go around the circuit, you lose voltage at the first resistor. How much voltage do you lose at the first resistor? Minus I times or. Because remember, voltage is I or. And then you continue moving around. How much voltage do you lose here? Well, you actually know it from the voltmeter. What is it? 11. So there you go. By solving this, you can get the OR. So 11, so OR will be 1 over 9.17, which will be 0.109. That's okay. 3 marks. 3 nice little marks.
What question now with this?
Can't remember what the electricity question is like in section A.
Should be easy. Can you come up with the question A blank C? Then we just fill in the blank B.
What do you mean, multiple choice?
No. A
Yeah.
blank C.
Yes.
And then we just fill in the blank B.
Like what blank? What would you put in?
B. A B C D. Can do that.
You want me to test you on your alphabet? A, B, C, D, blank. Oh. E? Right, the last part. Explain why, if you use 8 1.5 volt batteries, you would not be able to start the engine. So this is actually an engine, a car engine or something like this. Anyways, they want to know if... Yep.
You are reading 16.
Sorry, 15C now.
Oh, okay.
Yeah. Explain why 8 1.5 volt batteries would not be able to start the car engine.
It's over resistant to.
No, like, you see this diagram here? What's the voltage of this big battery here? It's 12. And this 1.2 is supposed to be a car engine or car lights or whatever. So they want to know, you've all seen a car battery before, right? So it's this big box, isn't it? And it's 12 volts. Now how much are those AA batteries? They're 1.5 volts. You know the little AA batteries? So if you have 8 of these little batteries, it also will have 12 volts if you put them back to back. So if you replace your big car battery of 12 volts with 8 of these little batteries, although it's still 12 volts, will the car engine start and the lights work or not?
Yeah.
No, yes or no first?
No.
Yes.
No. And the reason? No,
Efficiency is not 100%.
No. no, no, no.
Because the resistance is different or something.
Not quite. No. You seem confused.
Usually with internal.
No, 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 no,
Each
no.
one will not make 1.5.
No, 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 no. This isn't the problem.
Resistance,
No, you're thinking too complicated. Simplify it.
In the resistance bit in the.
No, it's too complicated. No. Simplify it.
How to see?
You're thinking too complicated.
It will take too much time.
No, too complicated.
Equal resistance.
No. What you care about is not the voltage, but the power. And the power from 8 AA batteries will be IV. That's from the 8 batteries. And the power from the big battery is also IV. True, the V's will both be 12. 12I and 12I. But the I's will definitely be different. Those little AA batteries, there's not going to be much current from them. Whereas with a big battery, there can be lots of current. In other words, although 8 batteries have the same voltage, it cannot provide the same power. And it is power that you care about, not voltage. Right? Take an extreme example. If you take your battery from your watch and put it into a car, even if the voltage was the same, 12 volt battery in your watch, will it be able to start the car engine?
No.
No, because the battery would have not enough energy in it. It would instantly just be used up, doing nothing almost. You know? How many joules of energy are going to be in a small AA battery? Not enough to maybe get 1 or 2 seconds of power for the car. Whereas with those big car batteries, there's lots of chemical energy stored inside it. Yeah.
Is it current is determine the amount of the power, the amount of something?
Yeah, what determines the current in a battery? Well, if you remember with a battery, how to make a very simple battery, we need some kind of acid. What?
Potatoes.
Potatoes is one, yes, you're right. And then we need 2 types of metals, or 2 types of material here. What were the 2 types I think we used last time in class?
And that
Lead was one, and copper, wasn't it? Lead, and then copper. And then there's a reaction here, which you learn from chemistry. When you put the metals into the acid here, they react, and a current flows. How does it flow? What is the movement of the charge? Is it electrons or is it ions?
Ions.
It's ions, okay? So what is current? Current is charge per second. So it's Coulomb per second. And what's carrying the Coulomb charge here? The ions. So in other words, the current is determined by how many ions can flow per second. So with a big battery and a big pieces of metal, you can have lots of ions flowing, meaning you can have lots of coulombs per second, meaning that you can have lots of amps, meaning that if your I is big, then I multiply V will be big, which means your power will be big. Whereas with those small little batteries, the piece of metal inside it, if there is metal inside it, will just be this tiny little like needle. So there's not going to be many ions flowing from that surface to the other surface. Okay? So that is what determines the current. Really, it comes down to how big the acid tank is and how big the metal plates are and how much reaction, chemical reaction is taking place. Okay? Yeah.
So like if like this battery is enough for this, like the current is enough for this. Let's say I got two batteries.
Yeah.
One has more current
Yeah.
and less current.
Yes.
But both of them can support me. So the more current will be support longer, right? Like than the less.
Yes, correct. Yeah, because the projector will not make use of all the coulombs per second. Yeah. So it means it will last longer. Yeah.
So like our phones, they are looking for the MAH.
Your phone?
Everyone was looking for that. Like
Yeah.
having the power bank or whatever.
The As you probably know with your smartphones, how long do they last before they die? What's the? I mean, like before charging up, how long do you get out of it?
Mostly 10 hours.
10 hours?
1 day.
1 day? Just 1 day?
Like almost
How often do you charge up your phone? Habib?
Every night.
Once a day. Amr?
once
Once a day? Once a day?
once a day.
Once a day? Once a day. You know how often I charge up my phone?
2 days. 2 days.
Once a week.
Maybe even once per 2 weeks.
This phone, the small one,
Yeah.
maybe once every 2 weeks.
Yep. This phone here. Look at how great this phone is. Why does although it's the same, in fact my battery is probably smaller and weaker than your battery, so why does this last longer?
Usage
It's
less.
It uses less, okay? So if I take your battery and put it into my phone, they both have the same, okay, they both have the same voltage, 6 volts or whatever. If I put your battery in my phone, this will last even longer. But if I put my battery in your phone might not even turn on. Okay? But why does, as a matter of interest, why does your phone use more power than my phone? After all, they're both phones.
no,
The screen is
First the screen.
Yeah.
It's smaller.
And the processor.
processing.
Processor, I don't even think there's much of a processor in this. What else? Anything else?
The brightness. The intake of all of it.
What do you mean?
Touch screen always affects the
Touch screen, yeah. There's no touch screen here.
Music, money.
Yes, I suspect the 2 things that use up the most power on your phone is the screen, okay, and also the processing when you're watching videos. Because on my laptop, when my battery is low, I can get a good few more minutes out of it if I turn my screen brightness down.
Yeah.
So screen brightness might actually be 50% of the power usage. So small screen, less power used. Okay? Right, 16 now. Do you do this in chemistry? With the last one, yeah?
See, yeah.
Yeah, so it's simply a matter that 8 batteries will not provide enough power. In other words, it's more than voltage that needs to be the same. It also needs to be the current. A small battery will not provide much current. Use your English skills to put that in your own words.